Okay, guys, let's take a look at these. I know some of you had some confusion on the last couple because a couple of you didn't know them. What we're looking at here was yesterday we could choose from 3 similarity postulates: angle-angle similarity postulate, side-side-side similarity postulate, and side-angle-side similarity postulate. When we're looking at the sides have to be in a proportion. The ratios must be equal, okay? So that's what we had to do. We had to see. Oops, number 1, not equal. It's not similar. Number 2 was equal. They all reduced to 1/6. So I could come up with a similarity statement. Any questions about number 2? Okay, let's take a look at, here we go. Number 3. We had this angle right here. What do we call those kind of angles? Vertical angles, and we know that vertical angles are congruent. Good. So this is side angle side similarity postulate because I looked at the ratios and they were the same. So I'm good. I can do side angle side. Number 4 was angle angle similarity. And check your similarity statements for 3 and 4. See if you have any questions. Are you checking?
I am.
Okay, number 5 is no good. No good. We've got 1 congruent angle here. That's it. We've only got 1 pair of congruent angles. We have to at least have 2, or we have to know something about the sides. We have no side measures, so can't do anything with it. We cannot prove similarity. Number 6, though, we can. We can prove that it is not similar because we can do 16 on the small triangle. It is to 88 as 25 is to, where did I get the 132? 25 plus 107 is 132. Those are not equivalent. Therefore, we cannot prove similarity. Any questions about number 6? Okay, number 7. We have all 3 sides on both triangles. We look at the proportion here. Everything reduces to 5/14. So it's side-side-side similarity postulate. This one, once again, we only have 1 set of congruent angles, nothing else. 1 pair does us no good. So cannot state that they are similar. All right, any questions about those 2, 7 or 8? All right, let's take a look at 9 and 10. 9, we're good. We have the 61, and then we have this set of vertical angles right here, so angle, angle. And you can write the similarity statement, HTS. Then this is side, angle, side. If we look at the sides, they reduce 1 to 3. Side, angle, side similarity. And here's my statement. Complete it with triangle UVW. Any questions? All right. Okay, and number 11. I had to find some missing information here. And there's 2 ways I could have done this one. I could have done it side, 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 or side, angle, side, because the angle F is part of both triangles, isn't it? So that would be the reflexive property there on angle F, that the measure of angle F is congruent to itself. So you could have gone either method, side, side, side similarity or side, angle, side similarity. And this is side, angle, side similarity. And there's our congruence. Excuse me, not congruence, our similarity statement. Today we're doing congruence. Yesterday we did similarity. Okay, questions?
I got it right.
All right, let's keep doing then. Okay, on the next page, we printed this from a software program, and I don't like this because it did not give me the similarity statement. So it's hard to tell. I'm guessing what my corresponding sides are. I write all the tests and quizzes. On a test or quiz, I wouldn't give you something like this without giving you the similarity statement. It does say the triangles in each pair are similar, but we don't know what the corresponding sides are. You had to do some guessing. And the way I guessed was I said, okay, big side with big side and little side with little side. That's all I could do was guess. So on this top part, that's how I set them up. I said, all right, 33 is the smaller one. Which one looks smaller here? I'll go with that one. So x is to 33 as 28 is to 42. Cross multiply and solve. And that's how I set up all of these. I had to do a little bit of guessing to figure out which side went with which side.
So we don't have the exact same answers.
You should have the, okay. on a test or quiz, you should have the exact same answer if I give you the similarity statement. I went with what side looked the biggest on each one to which side looked the biggest on each one. So that's really was our only option on here, which is not, let me say that again, not a good way to do it. Having the similarity statements the way to go. But check these, see if you have any questions about what I've done.
I got 16 wrong.
I told you.
3 square root of 13.
Because that was busy.
Oh, you assumed a right angle that wasn't there.
Yeah, I guess.
But I was making assumptions too, so.
So.
So that cancels out.
We'll say that cancels for today. Corey, you left your homework in here from the other day. Did you want it? Would you like to recycle it?
I'll just recycle it.
Okay, it's right there in my top bin.
Nice, Corey.
All right, has everybody had a chance to check this and we're good? See it right here? Right there. Okay, now, just like on the top section, I had to do a little assuming on this section. So I said, okay, this 11x minus 4 looks like the longest one on that triangle. So I'll put it with the longest piece of data I have on the other triangle, the longest side. So I'm looking and going long with long, short over short. So I said the short side, the 70 would go with the 50, the x minus 4 with the 60, and then you have a proportion. You can simplify, cross multiply, and solve. Did you have to set it up my way? Oh, no.
Not necessarily.
No, not at all. Not. My head went, okay, big over little. You may have done little over big. Yes, sir.
Did you round these?
No, they're exact.
So I just got these wrong.
Yes.
Yeah. Come on, dude.
Like
Which one?
I got, and it made sense.
8/10
And
away.
just from the way the triangles are, you
Which
think
one?
Exactly.
that's how I did it. But like,
I'm not
if
gonna
you
be
looked
here
at it,
tomorrow.
that wouldn't make sense.
You put 99 in, it's like 1,000. Okay, so take a look at these, see if you have any questions. I'll give you just a moment.
But it still works.
Oh, it is?
Yeah. Are you taking a charter bus?
Food bus. I think you have to take a bus. Yeah. You had to take a school bus. You're like, school and past school hours. Sports? Actually, Coach Mill made that rule for football.
Yeah.
So we can. That's for field training. You're like, yeah, we'll just cut the funding out. Actually, that was just about to check on your school bus. The rest of it is drive to the other side of the road.
Corey, when I was in high school, we drove from the middle Georgia to Memphis, which is on the other side of Tennessee.
That's like.
We were in the bus like 11 hours, a school bus.
I would be proud.
I have to drive to West Virginia. I have to drive to West Virginia this summer on the school bus. Oh,
You spit on it.
227.
You spit on it. Spit on it.
Sorry, I can't help it. I really.
All right, here we go. Okay, let's take a look at this, guys. We have been doing similarity. Today we're going to start congruence. So let's remind ourselves of what congruence means. Congruence are when all the parts of one figure are congruent to all the corresponding parts of another figure. So if we had congruent triangles and we were to cut one of them out, it would fit exactly on top of the other because all the sides would be congruent and all the angles would be congruent. That's what congruent figures are. The first congruence postulate we're going to talk about is side, side, side. We just did it with similarity, and they're similar if their sides are in proportion. They are congruent if we have 3 congruent sides. Side, side, side. Now, here we have a picture. It is marked. It's showing us the congruence. This one mark here on AC tells us that segment AC is congruent to segment, which one is it congruent to? ED or DE. Okay, and then AB is congruent to, which one? EF, because both of those have 2 tick marks. Now, is AC congruent to EF? No, because they have a different number of tick marks. Not necessarily. And then BC is congruent to FD. And that's what the tick marks mean. So these 2 triangles are congruent. Triangle ABC is congruent to triangle EFD. And the order of the letters matter. The corresponding angles must be in the same position. Angle A with angle E. Angle B and angle F. Angle C and angle D. This is our congruence statement, that triangle ABC is congruent to triangle EFD. Any questions about side, side, side? Side, side, side congruence postulate. Okay, so we're looking at these, and we're trying to figure out, is the congruence statement true? Well, let's look at it and see if they're even congruent to start with. So if we look at this, we have this triangle here. There's one. And then the other one is here. Okay, there's the other. Do you see that they share that side? AC? Okay. Is AC congruent to itself? Yes. And do y'all know there's a special term for that when we say that something is congruent to itself? It's called the reflexive property. When we say a side is congruent to itself. So they look congruent, don't they? Now let's see, is the congruent statement correct? Angle A of this triangle corresponds to what angle on the other one? C. So check, that one works. Okay, then we went angle C. So angle C here would correspond to which angle? Angle A. So C to A, ruh-roh. So it should be triangle C, A, D, wouldn't it? So this statement was not correct. Okay, is this congruent statement correct? Take a look at this picture. Same picture, but is that statement? Okay, so A, B, C is congruent to C, D, A. Yes, this one is correct. Okay, you look at the U-tries below and see if either of these are correct. And if they're not, I want you to correct the second triangle in each one of them. Correct the second triangle. Okay, so what was this one? What could we do to make this correct? YXZ. And what could we do to make this one correct? ZYX. Okay, any questions about side, side, side? All right, we're going to skip around just, no, we're not. We're going to go straight to this. Example 2. All right, some of you have done formal geometry proofs before, and you may have been scared of them. You may not have liked them, but they're not hard, and we're going to go through them nice and slow, and they actually make a whole lot of sense. They're really just logical. So we're going to do them slowly so that they're not scary. Let's take a look at this. It says, given that AB is congruent to CB and D is the midpoint of AC, prove that this triangle is congruent to this triangle. All right, the first thing we want to do is mark what this told us must be true on our picture. AB congruent to CB. What do we need to do? Put a tick mark here and a tick mark there. Okay, then it tells us that D is the midpoint of AC. What does that mean that D does to AC?
Splits it perfectly in two.
Splits it perfectly in two. Cuts it in half. So that would have to be the same as that, wouldn't it?
So EB is perpendicular to AC.
Okay.
Oh.
Now,
I just messed up.
do you see that BD would have to be congruent to itself? And I would just put 3 little tick marks on that to show it's congruent to itself. So when I come down here to do my proof, I don't forget about it. So is triangle ABD congruent to triangle CBD? Yes, that's what we're trying to prove. And that will always be our last statement. So our last statement is that prove statement. Triangle ABD is congruent to triangle CBD. And we can already tell from our markings what mathematical reasoning we're given for that. This is the side, side, side congruence postulate. Okay? Now, we have to prove why we know this is true. And to prove why we know it's true, we always start with what we're given. So the first thing we were given is AB is congruent to CB. That was just given to us. And then the other thing we were given was D is the midpoint of AC. We were given that.
Did you also write that DB is perpendicular to AC?
We don't know that that's true. Okay, could we prove that's true? There's a possibility. Yes, we could, but that's not the proof we're doing right now. It'd be a much more difficult proof. Okay, now, does D is the midpoint of AC tell us anything else?
Yes.
Okay, what did it tell us? That AD is congruent to DC or CD. Why? Why is that true? The definition of the midpoint. Because what does the definition of the midpoint do? It's the midpoint divides a segment into 2 congruent segments. That is the definition of midpoint. Good. Okay, so I'm showing 1 pair of sides, 2 pair of sides. What do I need here? I need that 3rd pair of sides, don't I? So what is that? I have not explained this yet. So that would need to be the DB is congruent to, I said DB and then I wrote BD. Reflexive property. Okay, any questions on side, side, side used in a proof? Okay. The next thing we're going to talk about is side angle side. That is our next congruence postulate. And side angle side says that if 2 sides in the included angle of one triangle are congruent to 2 sides in the included angle of a second triangle, then those 2 triangles are congruent. Side angle side. So a side, an included angle, and another side. All right, and then let's look at those problems. So here we go. We have 1 tick, angle mark, 2 ticks. We have 1 tick, angle mark, 2 ticks. Are they congruent? Yes. They are congruent by side, angle, side, congruence postulate. Now we have to be careful when we name them though. A, this one started out A, B, C. So A is the angle. So this one better start with F. Did it?
No.
Rut-row. Wrong. Let's fix it. So triangle F. What corresponds with B on this one? E. And then D. F-E-D. Okay? Now let's look at some other problems with these. Is there enough information in example 4 to prove the triangles are congruent by side, angle, side?
Yeah.
1 tick, angle, 2 ticks. 1 tick, angle, 2 ticks. Yes. Is this congruent statement correct?
No. Yes. Hold on. No, it's not.
Okay, what's wrong?
DCE.
DCE. DCE. Okay. You try the one below it. There's not enough marked, but is there enough that we know must be true? What do we know must be true? This must equal this because they are vertical angles, and vertical angles are congruent.
What would we write in the proof for that? Would we say property of vertical angles are congruent?
No, you would say angle ACB is congruent to angle ECB because vertical angles are congruent.
So angle ACB and
Okay.
ECB, and then just for the reason because vertical
You
angles.
just say vertical and congruent. You don't have to say because. Just vertical angles are congruent. Okay. This was not right though, was it? What does that congruent statement need to be? Triangle what? ECD. Okay. What? I will not draw things to scale on purpose.
That makes me mad.
Because I don't want you to look at it and go, oh, those look right. Yes.
But they could.
Oh, those don't look right. No.
Trying to trick
A little bit. A little bit.
No, not really.
All right. Okay, let's skip to angle 6. Not angle 6. Example 6, because this is our side angle side proof.
Where's example 6? Oh, I see it.
Okay, good. All right, given that B is the midpoint of AE and B is the midpoint of CD, prove that this must be true. So let's mark everything we must know on our picture. B is the midpoint of AE. What does that tell us? AB is congruent to BE. Okay, and now we're going with the one that DB just said, that because B is the midpoint of CD, then that is congruent to that. Okay, once, and then very good, Evan. This angle right here must be congruent to that angle because vertical angles are congruent. Okay, so how are we proving this? We're proving that triangle, come on, triangle ABD is congruent to triangle EBC. How can we state that? Side angle side congruence postulate. Okay, so we know where we need to get to. And now let's go back to where we have to start. We always start with the given. B is the midpoint of AE. Why is that true? It was given. And what does that tell us?
That A
AB is congruent to BE. Fabulous. Why? Good. Definition of midpoint. Okay? And that's all I can get out of that. Now let's go to my next given. B is the midpoint of CD. It was given. What does that tell me?
That tells you that BB is congruent to BC.
Is congruent to BC. Definition of midpoint. Okay, so I took care of those ticks. Now I got to deal with the angles. So angle ABD is congruent to angle EBC. Why? Good. Vertical angles are congruent. Vertical angles are congruent. It's a while.
Wait, when do we?
Okay, guys, the class is not over until 2:27, so we've got about 12 more minutes, and I'm going to use them.
I was asking.
Oh.
Let you answer my question.
Okay. There's one more we're going to do today because I'm not going to be here tomorrow. I have a doctor's appointment, so I won't be here tomorrow. So let me tell you, after we do hypotenuse leg, you don't have any homework on hypotenuse leg. But I am going to leave you some additional problems tomorrow that will have a hypotenuse leg on it. After we finish up hypotenuse leg, tomorrow I will leave a video on the other two, which are angle side angle and angle angle side. So that will round out all of our congruence statements. Now, sometimes I get excited about these letters, S's and A's, and we just put them in together in any form we want. But there is one that is not a congruence postulate. It's the angle side side, the donkey. Take a moment. Did everybody get it?
Yeah. Is there a side
Okay.
angle? There is no angle side.
There is no angle side side.
There's only side angle side.
Okay. The donkey is not a congruence postulate, and I don't say. And we don't say words that could be interpreted incorrectly in our math class. So we will call that one the donkey. Is not. Yeah, but this is Willoughby World. We don't talk about that here.
But you wouldn't say the
Okay.
SAS congruent postulate.
Huh?
You wouldn't say like the SAS congruent postulate.
Right.
You'd end up saying it's the ASS congruent postulate, but it's not a.
It's not. It's not. It's the donkey, and we don't say it. All right. So let's finish up the one we are going to talk about today, which is the hypotenuse leg. Just to remind yourselves, on a right triangle, the legs are the sides that are attached to the right angle, and the hypotenuse is always across from the right angle. It's along the side of a triangle. All right. So the hypotenuse leg congruence theorem tells us that if the hypotenuse of a leg of a right triangle is congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. Okay? So, that's what hypotenuse leg is. And we'll flip back to example 5. Sorry about all the flipping, guys. Here's a picture. Is there enough information to prove triangles congruent by HL, hypotenuse leg? Yes, there is. First of all, it has to be a right triangle. You can't throw out HL if you don't see a right angle somewhere. So, yes, right angle, check. Do I know the hypotenuse? Check. Do I know a leg?
Yes.
We do, because we know that BC is congruent to itself. Reflexive property. So, is there enough information? Yes.
Goodness. Mine is the side angle side too.
BC.
No,
No,
'cause it's a
it
side.
is the ASS.
Oh, it is.
Yes,
Oh.
angle side.
So it's a
It is the donkey, which we cannot use.
So on a test, you
Okay.
refer to it as the donkey. I'm going to put the donkey under an answer.
You would say, I cannot prove these, and you don't have to say why. All right, BC is, now, there is something called a little s, big S. We're not doing that.
That sounds terrible.
Yeah, we're not doing that. So,
I don't know. Just sounds terrible.
right. And some, if we were taking a full geometry course, we might discuss it then, but we're not. All right, so BC is congruent to itself, reflexive. Therefore, triangle A, that's not an A, try again, Wendy. A, B, C is congruent to triangle. What corresponds to A? D. What corresponds to B?
Doobie. Oh, sorry. C.
C. And what corresponds to C?
B.
B. All right. So triangle ABC is congruent to triangle DCB. Okay? All right, let's do the last proof of the day. This is example 7, maybe? Yes, it is. Example 7. All right, example 7 states that AB is congruent to DC. Mark your picture. AB congruent DC. It also tells us that BA is perpendicular to AC. Perpendicular tells me what? Right angle. And CD is perpendicular to BD. Right angle. Okay. I'm of the opinion that we need to add one little box to this. That was terrible. So let's add one little box.
It's funny right there.
All right.
Yeah.
Now, I know these are congruent. I know triangle A, B, C is congruent to triangle D, C, B, Y, HL. Okay, because BC is congruent to itself. So we must start, how do we start every proof? With the given. AB, segment AB congruent to segment DC. Given. Okay, does that lead us to anything else? Does that statement give us a follow-up? Nope. All right, so let's go to the next given. BA is perpendicular to AC. Given. That obviously tells us something. Perpendicular tells me what? What did I mark on my pic? Okay. Angle BAC is a right angle. Okay. And that is because of the definition of what? Perpendicular lines. If lines are perpendicular, they form a right angle. So this is perpendicular line, so that must be a right angle. Okay, so this naturally led into that. Tell me perpendicular, that means right angle. Nothing else I can do there. Let's go to the next given. What was the next given? Given. And because I know that, then I know that angle CDB is a right angle. Definition of perpendicular lines. Okay, I talked about this. I talked about this. I talked about this. I'm missing this. So what's my last statement? BC is congruent to itself. And yes, when I say something is congruent to itself, I use reflexive property. DB, don't break pencils in class.
It was already broken, sorry. No, like the
Snap that.
a little.
Okay, now it's more broken.
Yes.
All right, your homework is just the first little section on side, 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 and side, angle, side. I think it's like 19 problems. Okay, they are quick though. Read the directions. There's not a lot to it. One side tells us to state if they're congruent and why you know. The second side tells us what additional information must we know in order to prove them using the postulate they gave you. Okay? If it takes you more than 3 or 4 minutes, we're doing something wrong.
Whoa.
Really ready.
Some work slow.